Hello, everybody. Hello, my friends. We're back to our awesome YouTube channel about Kotlin. And today we have the next webinar. Actually, it's the last in the series. I've lost the count how many we have done during May, probably 4 or 5. But today we have Simon with some interesting content for us about building apps with Kotlin and Arrow.kt. And I guess it will be with Ktor, the framework that is built by the team at JetBrains. That will be interesting. Simon has some very cool stuff for us, and let's welcome him to the show. Hello, Simon.
Hey, Anton. Hey, everyone. Thank you so much for having me here.
Cool. So as usual, we have a lot of folks on the stream, and they are watching us. And folks, we are streaming to YouTube and Twitch. So if you ask questions, we see those questions, and we are going to address them as they come, like as it feels appropriate. Simon is going to deliver this presentation, and I'm going to stay on the stream with him to be able to interrupt him for the questions. I'm going to monitor anything you want or anything that feels relevant. And if you haven't subscribed to this YouTube channel, you should. We will have more webinars coming in a few months. So in order not to miss, you have to subscribe. Otherwise, Simon, the floor is yours, and let's go.
All right. Thank you so much. Before I want to get started, I want to mention that if you do have any questions, be sure to shoot them in the chat and we'll definitely try to answer them as they come. If you do not get your question during the stream, be sure to hit me up on Kotlin Slack or any of the other Arrow maintainers, or hit me up on Twitter with any of your questions or your doubts, and I'll be happy to help you out and answer them. So what I wanted to do today for this stream is I wanted to show a full horizontal slice in a backend application built with Kotlin and Arrow, because we've gotten a lot of questions in the past about Arrow and how it can be used to build full-fledged applications. Because most of the presentation talks and examples that we see are typically isolated to small use cases and not, big horizontal features that you would typically build in a Scrum way or something like that. So I went looking around for a good example application, and what I came across was this RealWorld application, and it's called the mother of all demo apps. So that to me sounded great. And what they try to do is they try to mimic or rebuild a medium.com like website. And what we're going to be doing today is we're going to be building the backend for it. And what this makes this initiative so interesting is that there's many applications, both for the backend and the front end. And if we, for example, take a look at the backend applications that we can find today in Kotlin, you can already see a bunch of them there right available. We can click through on them, find them on GitHub, browse the code. And this is actually really cool because you can compare the code that we'll be seeing today to any other of the existing implementations that are already out there with different frameworks like HTTP4K or Spring or Quarkus. Today we'll be using Ktor, like Anton already mentioned, in combination with Arrow. And then the full project you can find on my GitHub repository. It's still a work in progress, so you will not find all of functionality there yet. But there's some issues, there's some pull requests. It's a work in progress. What I prepared today for the webinar is a separate repo that only has the code that we'll be seeing today, so the horizontal slice we'll be seeing today. There's also 2 PRs open in the repository. These are things that I would like or love to discuss today, but I'm not sure if we'll have enough time. If you're interested, if you did not get to that point, jump into the PRs. Feel free to ask some questions there or anywhere else, and I can help you out. And maybe I will see Anton, next series, and we can talk about any of the other topics that we were not able to cover today. So for performance reasons, I'm going to close all my Chrome windows, and I'm going to jump to the Open API spec of the RealWorld application. So this RealWorld application comes with an Open API spec that we need to adhere to, because there are front ends built in other languages that are built against this Open API spec or the contract that this RealWorld application provides. So The horizontal slice that I want to look at today is registering a user. And as you can see here, we have the API path. We have what they expect in the request, both in the headers and in the body. And we have an example that we can run, and we have the response that is expected from us. I see some funny questions about my mustache. So yeah, some people might remember me as the guy with the big beard. During COVID, the beard disappeared and that became a mustache. So let's look at the actual application. So before we dig into any code, let's see what kind of technology or libraries that we're using in this application. So naturally, we're using Arrow, as most of you might have already suspect. I'm also using a GWT library, which is built for Kotlin, hence the K in front, but it also is built upon Arrow, so that's very interesting for us. I'm using a bunch of Ktor dependencies, and these are the versions or the split in modules that you can see that happened in the 2.0 version. So we are working today with Ktor 2.0 already. And I'm also using SqlDelight, which I think is a very interesting library. And for SqlDelight, I'm actually also using the 2.00 alpha version, because in the 2.00 alpha version, they enabled Postgres support, or better Postgres support, which is what we will be using in the microservice today. And another great thing about this is all the libraries that we've seen above, they're all multi-platform. I would really love to make this example multi-platform. I'm currently stuck to the JVM for a single library. I hope to solve that in the near future.
We can mention here that with Ktor 2.0, you can actually build native apps as well.
Right. So that was exactly one of my points that I wanted to go here. Ktor 2.0 allows for building native applications, which is super awesome. So yeah, it would be really cool if we can make this crypto library multi-platform, and then we can actually run our Ktor server on Mac or Windows or anywhere we want. So let's jump to the main function. And in the main function, there's already a bunch of stuff going on. Most of you people that are familiar with Ktor might be familiar with the embedded server DSL. So this piece that we have inside is the DSL from Ktor to start a server using Netty. But what is interesting is the stuff that we have around of it. So let's first look at this. And some of you might have expected to run blocking here. I'm not using run blocking here. I'm using a custom variant of run blocking. And the reason for that is this embedded server is launched on a coroutine scope. And because I'm so in love with structured concurrency and Kotlin coroutines, I want to use that all over the place. So typically my embedded server would inherit the coroutine scope from the run blocking. In this case, it inherits it from cancel on shutdown. And what it will do is it will cancel this inner coroutine scope on a shutdown signal from the JVM. And that makes sure that if Kubernetes or Docker tries to kill my server, that it will actually gracefully shut down my server, and it will also shut down the resources that I'm using here in this block. So what is this environment here? This environment is my version of configuration. So typically are very common in the current communities using something like application.conf, where we typically rely on system or environment variables and then default values. Instead of using application conf, I chose here to use just regular data classes, and I'm assigning them either the system variable or some default value. For that reason, I don't have to maintain some application.conf file or an XML file. I don't have to use any libraries that load and convert my config file into a data class. I'm just merging everything to a single data class because that's what works very well for me. And of course, the data classes or vanilla Kotlin are super flexible. I can refactor or remodel them in whatever way I want very easily later on. So what is this dependencies? And dependencies is the first Arrow-related thing that we'll be seeing in our webinar. this dependencies is a resource, and that is what allowed us to call use on the dependencies result. So some of you might already be familiar with the use function from the standard library, which is projected over any type that inherits closable or auto-closable from the JVM. In Arrow, we have this resource data type that allows you to model resources in a slightly different way than auto-closable or closable. And then we have these nice DSLs to compose them. So let's take a look at how we can initialize or create a resource. Here, I have a Hikari function, which takes a part of my configuration, in this case, the data source, which has the Postgres URL, the username, the password, and then the driver that I want to be using. And I am creating the Hikari config from my own config data class. I'm then initializing the data source, and I'm passing that to the from closable constructor. So what is happening if you call use on this resource? It will call this function block, initializing the data source. It will hand you the data source in the use block. And then when your code is finished, it will close the Hikari data source. So it works exactly the same as you might have expected from us calling use directly here on this data source. So why do we want to use resource instead of just using closable? Because resource composes. And here we can see a different example. We can create a resource for SqlDelight based on any data source. And we can do so by opening the resource DSL, creating another closable data source, but we are transforming our data source to a JDBC driver. And this is a type from SqlDelight. This is what SqlDelight is going to use to run all the queries that we write. We can also use the driver to create the schema or do migrations on the schema later on. And we can then eventually initialize SqlDelight. And if we go back to our dependencies block, we can also see here that we can initialize our data source and we can call bind on it. And when we call bind on our resource, this gives us the inner value on the left-hand side. So now that we have this data source on the left-hand side, we can continue to call or create our SqlDelight resource, which we can again call bind on. That gives us the instance of SqlDelight, and we can then use those two resources to construct the rest of our dependency graph. And in this case, our dependency graph only has a user service because the only thing that we're currently implementing is the horizontal layer of the user registration. Not my questions so far, so I'm just going to go ahead and continue. So if we go back to our main function, we have now seen basically everything that is in this block. We have a variant from run blocking to cancel ourselves when this JVM gets shut down. We initialize our environments, we initialize our dependency graph, and we can then finally initialize our actual embedded server. And what are we doing in our server? We're setting up Ktor with default headers and content negotiation for Kotlin serialization. And we're then installing our user routes. So let's jump into our user routes. And as you can see here, we have a couple of data classes, and these data classes we have here in place so that we can be in compliance with our OpenAPI spec. So for example, we need to have this user object here inside of our JSON, which is what we use this user wrapper for, which creates the user label. We annotate it with serializable. Then we have a new user, which is the username, the password, and the email to register a new user. And then we have the actual user, which has the email, the GWT token, the username, the biography, and an image reference. And then we can go ahead in here and install our actual routes. So we are already in the API piece. So we just need to add the users part, and we can then add a post endpoint. And inside of our post endpoint, we are going to do three things, which is receive our input. Then I have a variant from the receive function from Ktor, which simply wraps the receive function in a catch with either. So this is going to give us either a throwable or a result of A. And we're then going to map our throwable to a typed error. And for those that are not yet familiar with this pattern, I can recommend you checking out the last video I did with Anton on the webinar, because there we have some discussions about either and validation, and we covered these concepts already. So I'm not going to go in too deeply into that now. But once we have the either of our expected input, we can bind to it and we can get our actual user out of it. And then the user was this new user data class, just to be clear. And then we can deconstruct that to the username, the email, the password, right? So that is how we can very neatly get the input from our post endpoint, and we can then pass that along to our user service, which is what we do in this next line. And before we jump into the user service, we can see that we then transform the results of our service layer into the type that our open API expects, and then respond from our endpoint. So the code inside of our endpoint is relatively simple. So what does our user layer look like? Our user layer, our service layer, our user service here should not be shocking to anyone. I think we have a separate data class that to split ourselves off from the Open API data class. So as you can see, this is exactly the same as the user that we had in the previous file, and the new user we had in the previous file. But for decoupling what we consider the Open API in the Ktor layer or the server layer and what we consider our business domain, we have decided to split these two domain classes.
Simon,
yes.
could you please repeat what was the bind for? There was a question in the chat.
So let's jump back. So our receive catching function is actually returning an either. So this doesn't type. So let's see what IntelliJ suggests here. So this receive catching function is either returning us an unexpected error or a user wrapper with a new user inside. But that is not really useful to us here. What we are actually interested in is only the happy path. So to code against the happy path, we can say, okay, I'm going to call bind, which is syntax that became available inside of this user block, because domain error has unexpected error as a subtype. So we can call bind on any error that is a subtype of domain error. And that gives us back the user wrapper, which was on the happy side or the right side of the either. But I'm not interested in the wrapper. So I'm going to immediately extract the user. And from that, I'm also going to extract or deconstruct the values that are inside, because that results in slightly better syntax than having to use the dot access syntax here for all these values.
Cool.
So going back to the user service, since we are only doing this horizontal slice from the register functionality, this user service only has a single function. And that might look really silly now, but if you look at a project that is already further along, you can see that this user interface actually has multiple operations, all the CRUD operations that you might expect for user registration. There is a way that we can remove this, but we'll see if we can get to that later. So Typically in the service layer, we are only composing different layers together. And that is also exactly what we can see here. We have the user persistence and the GWT service. And we'll dig deeper into both of those later. And then here we do exactly the same thing. We open an IDLE block. In this case, we're validating the data inside of our user service, because again, we want we consider validation of our input part of our business logic. We don't consider it part of our route. So that is why we chose to move it into the service layer. So also that we can do unit testing or whatever kind of testing we want on this business, what we consider business domain logic. Then we are simply, if we validated the input, we simply refer the insertion to the database. And then finally, we're going to generate the token based on the user ID that we get back to the database. So let's dissect this a little bit. What is this validate stuff actually doing? And for those that have watched the previous webinar, this already might seem a little bit familiar. We are here using the validated data type from Arrow. And in contrast to either, this will actually not short circuit when it finds an error on the left side. It will actually accumulate errors. And that is really useful here, because in this case, we can see that we're going to validate the username, the email, and the password. And ideally, we want to have all the incorrect inputs from that. So that you can see here, even in the case that all three are incorrect, we want to see all three errors and not the first one that we encountered during validation. So we actually want to accumulate all the errors like you would do on a form, where you want to show all the errors at the same time instead of all the answers separately. And the reason that you want to do this is, for example, in this way, if you move validation to the backend, and the front end would send a request to the backend, and we would return them, your username was not valid. He sends a new request, and we would then return to him, oh, now your username is valid, but your email is not valid. That would be really silly, but because this would require the client to call multiple times to get through the validation process instead of a single time in knowing all the fields that were wrong. And what is cool about validated and either in Arrow is that this function is actually returning a validated, but we can call bind on it like it was an either value. So what happens in this case is, if we have a set or a list of errors, in, for example, the email and the password did not match the requirements, and we call bind, then it will result in a domain error with both an invalid email and an invalid password. So after validation, we can finally go to our persistence layer. And our persistence layer, again, looks quite similar to our service layer. We have a value class for our serial, which is user ID, or our unique identifier for our users. And we have a simple insertion method on our interface user persistence. And before we go any further, I really want to show what SqlDelight looks like, because I think it has a really powerful API. So with SqlDelight, we get to define these SQ files. We get to define our SQL right inside, and it's going to generate code from our SQL, which I think is really powerful. So it's also going to validate that our SQL is correct. It has support for doing things like compile time verification for migrations, etc. So here we are creating a user table, which has the unique identifier as a user ID. So SqlDelight has support for custom types right from the SQL file. So here we can say that whenever you return an ID from the generated code, it needs to be of my own type, user ID. And then we have to provide a, as you might have seen in the dependencies, on persistence, sorry. You might notice that we have to provide an adapter for the column of the user ID. So we have to say how we can construct a user ID and how you can extract the user ID from our type. And furthermore, like I mentioned, with SqlDelight 2.0, which is currently still in alpha, it has support for Postgres, and we can use the returning ID statement right inside of our insertion here. So we don't have to do multiple queries anymore to insert the user and then get the ID or call any special SQL functions. No, we can just use specific Postgres syntax right from the SQ files, which I think is really amazing. And as you will see, it also makes our implementation hilariously simple. So since we're going to do some side effect to the database, I'm going to wrap that again in either catch. And here I'm going to call the insert and get ID function. And insert and get ID function expects the email, the username, and should be a hash password, but my autocomplete is not working. Right, but there's two problems here. There we go. First of all, we are now returning an either of throwable user ID when we were actually expecting a user error on the left side. So what can we do about that? We can again map left, and we here have the error of type throwable. Then I can, for example, do something funky like check if the exception was a unique violation. And what I'm doing here inside is pretty simple. It's just a predicate that says if this is a Postgres SQL exception and it was a unique violation, then it returns true. So in case it was a unique violation, I can assume, well, not really assume, I know for sure that the username already existed. Right. So instead of returning you an unexpected error, I'm going to give you a more specific typed error here. And you can take this as far as you want for any different kind of SQL exception that is important for you to be able to work with. And I can say the unexpected error was that we failed to insert the username into DB, and then I'm going to pass the actual error as a cause. And there's still one piece missing. We, of course, don't want to put our password as plain text into the database. That would not be very nice for our users. So I'm going to hash the password. And this was the Java library that I mentioned before, which is bcrypt. And it's a pretty well-known crypto algorithm for hashing passwords. And it's quite simple to hash your password. You can do it like this. And there we go. And now we have encrypted our password, or encrypted our password with a pretty well-known battle-tested encryption algorithm that should prove quite secure for our use cases. And for those wondering, if you want to verify the password,
Simon, we have an interesting question there.
Yeah.
Ivan is asking if the error is a restricted hierarchy. Is it a sealed class or something?
Well, let's take a look at that in a second. So to finish my sentence here, to verify the password, you call this with any incoming password, and you compare that using this with anything that you had in the database. So the errors, that is actually a really good question. The errors is indeed, it's a sealed interface, and at the very top of the hierarchy, we have domain error, and then we have several different errors along the way. So for example, we have a piece that is validation error, right? And in this case, because our model and our project is still quite small, it only has one error. Our user error, for example, has a couple. This is actually not in use because I removed the unique constraint from it. This is actually also not in use, but you can imagine what this would be used for. And then for the GWT error, we have the same thing. And this forms one big hierarchy, and you can be as fine-grained as you want along the way. And there is actually, with context receivers, some really cool stuff that you can even do more because they don't have to be a sealed hierarchy. They do not have to have any type relation to each other. We can completely separate this as well if you want. but I'm afraid that's going to be a topic for a different webinar. So yeah, now that we've seen the whole code or all of the code, let's see if we can actually run this. And we're going to try invoking it from Postgres. But just to show you in the meantime while it's building here, you can also write very interesting and very powerful integration tests with Ktor and TestContainers. I'm a big fan of TestContainers. So this is too good of a chance to pass it up to promote it. So I actually stopped investing so much on unit testing, especially on the back end, because with TestContainers, it's so easy and so fast to run integration tests locally. And as you can see here, you can see almost the same thing that we're going to do in a second in Postman. We have our client, we're going to post the user endpoint with a JSON content, and we're going to set the body. And then we're going to assert that the status is created, and we're going to check that all the values match as expected.
Now I have a question.
Yeah.
When you showed this Postgres SQL container line, there's this config function. Is that an extension function from where?
Yeah, so this Postgres, and this is a pattern that I've been using myself in production a lot. So we had an issue, first of all, that we were launching these containers all over the place, separately in every single suite, and that was causing too much of an overhead. Then I started digging more into TestContainers, and their official recommendation, as you can see here in the URL, is actually to start a singleton instance of the TestContainers, and they have a special system in place for shutting it down. So I'm actually just creating a singleton instance whenever somebody invokes it for the very first time, and then calling config. I'm just getting the config from the TestContainers and returning you the data class that we defined in the production code.
I see. The reason I asked is because when you start using extension functions with TestContainers, they are using a lot of this recursive generics in their API.
Right.
And there you can start hitting some corner cases with adding extension functions to this kind of types.
Yeah, so to solve that exact issue, I redefine Postgres container in my own domain, and I extend from Postgres container nothing. And that's, well, actually, that's not correct. If you do this, then that solves the problem, because this is the recursive generic. So if you have nothing, the chaining DSL from this container is still broken. But if we replace it with this, then that fixes the recursive generic Fluent API, I think they call it. The Fluent API that they have with the recursive generic is fixed if you have, well, the same recursion set up in your column types. Okay, so we are running on port 8080. So let's open the request. And there's probably a bunch of users already in my test database. So yeah, and this is actually not a correct email address. No, I think username one's gonna exist for sure. Boom, there we go. So the code that we've just written and talked about is working, as you can see here. This response was pretty slow. Let's see if we can shut down the server again. And as you can see, whenever I hit shutdown, it didn't immediately shut down. We got that skeleton right there. That means that we send a signal to the GVM that we do want to shut down, but we are not going to force kill it yet. And because of that, you can see here that the Hikari pool is starting to shut down, and that it closes all its connections and everything before it actually exits the GVM. And here you can see this is the signal that we send to the GVM with that stop button. We send a request to shut down the GVM. We didn't actually kill it. If you click on the skeleton, you do kill it. Okay, so let's go. Guess we still have some time left. Great. So let's go back to the user surface. Yeah, here we go. And I'm gonna skip showing the JWT because it is super straightforward. It's just generating a JWT token based on the user ID as you would do in any other application. If you're interested, the code is there. You can check it out. Okay, somebody asked a question here I see about destructuring.
Yeah.
Yeah, as you can see here, I obviously am a fan of destructuring. One of the reasons that I'm a fan is there's, I think, a pretty interesting analyzer in IntelliJ that tells me, hey, this is not correct. And if I'm not mistaken, that will also give me a warning at compile time. Of course, that is not guaranteed to solve any of your big issues. What actually I'm a big fan of, and there was also somebody asking that about value classes, and I'm very big on, I'm very big on value classes. I like to use them a lot. Maybe I even overuse them. And if you do overuse them, then you cannot make any mistakes here. For example, if you would actually type this to username, email, and password instead of string, then you cannot run into any issues here because this would not compile passing the wrong types around. So for that reason, I am a very big fan of value classes, but I'm not using them in this example. Typically, I start using them or I start adding them along the way as I see mistakes being made in the code or incorrect assumptions being made in tests, and then we try to fix those assumptions or we try to fix those regression bugs from happening again using value classes. Okay, so a big question actually from Hadi Hariri in the last weeks on Twitter was, why do we create so many interfaces? I'm not sure who saw his tweet about that, but I thought it was an interesting
I did.
question because I am personally a big fan of interfaces because it gives us a lot of benefits. But as you can see, it also introduces some overhead. And to be honest, this is probably the interface that I think is the most redundant in my whole in this whole code base. And the reason is that it's only relying on these two other interfaces that I am already controlling 100%. So why am I creating a third interface to hide these other two interfaces, right? That might be a question. And context receivers, which I am a growing fan of every day, they actually solve this issue. So what if we remove this interface completely and instead we say that this function is dependent on the user persistence and the JWT service? We can now have almost the exact same code, and we are still modeling the exact same thing. We are still saying that this register function has a dependency on user persistence and the JWT service without making them concrete in any way, right? So you can see this now turn gray because we're not calling it anymore. And I've also heard someone remark that it becomes increasingly difficult to find these functions if everything becomes top level functions. So, but since we're using context receivers, we are free to model our Kotlin code in any way we want. So we can now put this code actually in the user service without losing any benefits. So let's see how that changes our code. And first of all, it's going to change our dependency graph because we no longer have this user service. And I have a solution for that, Ivan. It's not auto-completing for me. Probably because I have some red stuff here. Right, so now our dependency graph is made out of the user persistence and the JWT service. And then if we now go to our main function, we will see that, yeah, this guy is now red here. So I'm going to propose for now, and maybe this is for simplicity, but you can go as fine-grained as you want in this. I'm going to say that my user route has a dependency on the JWT service and the user persistence. So, and then we can see that this code is no longer red, so it starts to compile. I can go back to my main function, and I can now say with the user persistence and with the JWT service.
Hey, that's not a genuine with function, I guess. It's your own.
No. Yeah, I need to remove this parameter because it doesn't exist anymore. And now it is compiling again, and we can see that we can run our code and it will be behaving the same as before. And as Anton guessed, this is a custom with method. Oh, it jumped on me. Right, so that was now a function on our service like this. Yeah, that seems to be working correctly. So this is indeed a custom with method that I have, and it requires actually a workaround, sadly, but it's already tracked. It's being worked on as far as I know, so it should be fixed soon. But what this with block is actually doing is instead of accepting a single argument, it's accepting multiple arguments, and it's making them available in the context of the Lambda of the with method. So since we are here passing the user persistence and the JWT surface, we are therefore satisfying this constraint of user persistence and JWT service. And as you can see, we are here constraining to interfaces. So this is very similar to having a third interface that then consumes the other two interfaces to build its implementation. And with this new implementation, let's try and register a third user. And as you can see, works fine. Do we still have some time?
I think so. Let me check. Yeah, we can have another 10 minutes or so.
Okay, then there's one last thing that I want to show, which is actually that second PR that we have. This is maybe going to be a little bit complex for some people, but let's try it anyway. So this is something brand new that we've been working on in Arrow, and I'm super excited about it. So in Kotlin, we are not a big fan of having these, nested return types in our function signatures. Ideally, we would just be seeing JWT token here, and this either would disappear there, and that would make our code look a lot better. I'm not sure if everyone agrees, at least I think so. So, but now you can see that there's a bunch of stuff turning red, more specifically this bind function. So what if we make, and if you remember correctly, this bind function was actually coming from our either DSL. So let's see if you still have it here. No. Do we have it somewhere else? Yeah, we have it here. So if we look inside of our either function, you can see that the DSL is coming from an EffectScope type, right? This EffectScope interface is what allows us to call bind on effects, eager effects, either, validated, result, and all the types that we're familiar with from Arrow and the standard library. So what if we could say that this function can only be called from an either DSL? We can say, okay, this function needs to be called in an EffectScope of domain error. Oh, that's better. And we can now see that we don't have to return either anymore in the return type because this bind syntax became available due to this interface in our context receivers. But to be honest, this looks a bit ugly. So let's try and improve that a little bit. What is interesting is that we can define a simple type alias, and we can call we can rename effect scope of domain error to domain errors, and we can now replace that in our context as domain errors. And we can now here say that our suspend function register, it expects a register user, it returns a GWT token, and it can only be called if you have the user persistence available, the GWT service available, and if you can handle any occurrences of any domain errors. And if we now go back to our user route, we can see that we don't have to call bind here anymore because register is not returning a either anymore. It's returning directly a effect scope, a GWT token. And since that we are satisfying the constraint of handling a domain error directly inside of this either lambda, right? So using this either of domain error makes sure that we can call this register function that can result in a domain error. All right, and that is pretty much all that I wanted to talk about and show you guys today. Yeah, I am really, really loving how we can do functional programming in Kotlin with Arrow, especially with the upcoming context receivers. I'm not sure if all of you can see the excitement on my face, but yeah, it's definitely there.
It's amazing how it all composes together and it's still elegant. And yes, you need some understanding of the concepts behind Arrow and behind some functional programming. For instance, when I see something like fold left, my brain starts kind of cracking a little bit, but well, I have to step back and refresh my knowledge about these concepts every time because I'm not using it every day. But once you get used to that, I believe, like even me, when I don't understand it at first glance, when I look at the code, I actually downloaded the project before the session and skimmed through the sources a little bit. It looks very nice. It looks beautiful, I would say.
Thank you.
All
Well,
right.
yeah, it's been a very big priority for us for all the Arrow maintainers and everybody behind Arrow to make it really elegant in the Kotlin language to make everything work very nicely and idiomatic. That was a very big point for us, and I think we've gone a very long way doing that.
What I also really like in this structure, in this project, is the concept of resources, how you can attach different resources and abstract them through, was it the Arrow API that was behind it?
Yeah. So
Yeah,
this resource data type is coming from the Arrow effects coroutines library.
that's really useful. Like I mean, it integrates to Ktor so well that you have this layer of abstraction and having it all commonized. Like if you have a database, if you have something else, then it kind of is all unified. It's beautiful.
Very happy to hear that. Thank you for the very nice feedback.
All right. Do we have any more questions? I can see all the excitement in the comments, but I don't see the questions. Like it's good to like I'm going to. Yeah, Arrow is amazing, really awesome. Effect scope is great. We are all excellent. Excited. Sorry. Uh, great talk. Yay! 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 The
Seems a lot of my
right.
friends showed up in the chat, but I want to thank everybody for the support, everybody in the Kotlin community. Yeah, it's a
All
really
right.
great community to be part of.
So okay, then let's wrap it up. So it was a very nice presentation, Simon. We're gonna publish it on our YouTube channel as usual. If you folks have not subscribed yet, you should. We will have all the resources, the links to the previous presentation about Arrow, the link to the repository down in the description below the video. And otherwise, let's keep in touch. And well, if like the summer passes, we will start new presentations, we will start new webinars, and I hope we'll have Simon again with some new awesome content about Arrow and functional programming as well.
I'd be happy to be here. And yeah, thanks everyone for coming in.
Cool. So bye-bye, everyone. Have a nice Kotlin.
Bye.